All right, this is our lesson for 6.4b. I can identify identify the domain and range of logarithmic functions. We've already done exponential growth and exponential decay functions. We are working with logarithmic functions today, which we learned about yesterday. So here is what our parent function looks like graphed of logarithmic functions. The first thing I would like to point out is that they have a vertical asymptote at x equals 0. Both of these graphs have a vertical asymptote at x equals 0. Recall that logarithmic functions are the inverse function of our exponential function, and exponential functions have a horizontal asymptote at y equals 0. And remember, when I take an inverse function, horizontal lines become vertical lines. So it makes sense that I have this vertical asymptote of um, with this log function. Okay, that's the first thing I would like to point out. The second thing I would like to point out, the difference between this graph on the left is that the base value is greater than 1, and the graph on the right, we have this particular shape when the base value is in between 0 and 1. We also have this interesting point right here where if I have a value of 1 for x, my output is 0. So essentially, what does that mean? B to some value, which is my output, um, to give will give me, I'm sorry, b to the 0 power will give me a value of 1. And so that is why we have this point 1 comma 0. My output is 0, which is the exponent. B to the 0 power will give me 1, and that is on both graphs. Okay, so those are the parent functions and what they look like. The procedure that we're going to use to actually graph logarithmic functions is as follows. So here is our procedure. First, we will determine the domain. If you recall from yesterday's lesson, the input to a logarithmic function, so whatever, I have this base, I have something in this parentheses, this has to be positive. And from that, we will use that input, um, we'll set that input equal to greater than 0, and from it we'll find our vertical asymptote. It would be nice if we knew our x-intercept, but it is not essential. But what we're for sure going to do is plot additional points, 2 of them, as needed to connect with the smooth curve, and there are 2 of them, and here's what we're going to use. We're going to use the fact that the log base A of 1 is equal to 0. What that says is a to the 0 power is equal to 1. And we know that no matter what a is, if I take it to the 0 power, my output will be 1. In addition, the log base A of a is equal to 1. Okay, so what does that mean? That means that if I take a to the first power, my output will be a. Okay, so we're going to use those properties of logarithmic functions to find those 2 points. Now, alternatively, you can use and memorize the parent logarithmic graphs and apply your transformations, either vertical or horizontal, and to be able to identify what has occurred to the graph. So if you recall, things that happen within the parent function are horizontal dilations, such as C. If C is, that will cause a horizontal dilation, and or a y-axis reflection. It would cause that if that C value is negative. In addition to that, H is within the parent function, and it will shift the graph right or left. And that is a very important value because that will help us identify where the vertical asymptote is located. This K value is outside of the parent function. Things that are outside are vertical translations, and so that will help identify whether the graph is shifted up or down. And A, once again, is also outside of the parent function, and it is going to tell us if there's a vertical dilation, or if it's negative, it would have an x-axis reflection. All right, so let's graph some of these, and hopefully the procedure that we have will make sense. The first step is to determine the domain. The input to the log must be positive, so we know that this value of x minus 1 must be greater than 0. That is a domain constraint that we learned in yesterday's lesson. So we know that x has to be greater than 1. So that is our domain. Domain will be x must be greater than 1, and our range will be all reals. Okay, there is our domain and there is our range. What we have essentially just found is our asymptote. And so let's kind of just sketch this real quick. We know that x, how about I do it like this? We know that x has to be I'm sorry, our vertical asymptote is located at x equals 1. So our values of x are going to get very, very close to 1, but they're never going to cross it. And so how I found that asymptote is I used this domain information, and I just changed that inequality sign to an equality sign, and there is my vertical asymptote. Now we got to find our two special points, and the points that we're going to use is when that value in the logarithmic function is equal to 1, and when that value within that logarithmic function is equal to the base, and the base in this case is 3. Now, what values of x make that happen? That will be x equals 2, and that will be x equals 4. So I essentially solved those two equations and found those two values of x that I'm interested in. Those will help us find convenient points to plot, and I'm going to now show you how to do that. Okay, so x will be equal to 2 and equal to 4. So what I'm going to do is plug in 2 into the the value of 2 for x, and 2 minus 1 gives me 1. So 3 to the what power gives me an output of 1? Well, 0, 3 to the 0 power. So now I will have this will be equal to 0, and 0 times 2 will give me an output for that function of 0. Now what we're going to do is take this 4 and plug it in for x. So 4 minus 1 is 3. 3 to what power? Log base 3 of 3 is equal to 1. So what that's asking for is 3 to what power equals 3? Well, that means that that output will be 1. 2 times 1 is 2. And so I have my value of my function when x is equal to 4. So that's how we find our two convenient points. We set what's in the the logarithmic function equal to 1, and we set it equal to the base. Now let's plot those two points. I have a point at 2 comma 0. We'll say that's approximately there, and I'll call that 2 comma 0. And I have a point at 4 comma 2, and I'm gonna be somewhere right here. And I will just move these out of the way, and I will have a graph that looks something like that. And so here was my table of values. I had a table 2, 0, and 4, 2. Okay. Now, why don't you try one? Welcome back. What's our steps? First step, we find our domain. This value, x plus 3, has to be positive, so it's got to be greater than 0. We find x to be greater than negative 3. That is my domain, and our range is all reals. What we essentially just found was our vertical asymptote. And so here is my x and y axis, and we have a vertical asymptote located at x is equal to negative 3. So I just take that domain and put an equality sign there, and there's where my vertical asymptote is located. Now I've got to find my two convenient points to plot. I take the input to the log, and I set it equal to 1, and I take the input to the log and I set it equal to the base, and the base in this case is 2. what values of x make that occur? I find the first one to be -2, and I find the second one to be -1. Now we'll come over here and plug those values into my function. I will plug in -2 and -1. And so what do I get? So I have this -2 that I'm going to plug in for x, and I have -2 plus 3 gives me a value of 1. 2 to the what power gives me 1, and that will be 0. And so the log base 2 of that value is 0. So that is the output of my function. And then I will plug in -1 for the value of x. -1 plus 3 gives me 2. 2 to the what power gives me 2. That's 1. And so now my output to that function is 1. Now I have these two convenient points that I can plot. I go to -2, so we'll say that's -2, 0. I'll call that -2, 0, right about there. And I have -1. Of course, I'm always in the wrong spot. I'll say this is -2, 0. And then I go to -1, 1. We'll say that's approximately there. That's -1, 1. And there is my graph. It's approaching -3 and goes through those plots. So if you were to shift your page 90 degrees, you'll see that it basically looks like an exponential function. All right, continuing on, we're going to graph the function and see. So what's my first step? I need to find my domain. Be very careful. The only input to that log is x. It is not x plus 2. If they wanted that to be the input to the log, it would have been in parentheses. So my domain is when x is greater than 0, because my input to my log must be a positive value, and my range is all reals. I have just essentially found my asymptote, which is located, it's again a vertical asymptote, and it is located at x is equal to 0. Okay, I now need to find my two special spot or points that are convenient. We find that we want that input to that log to be 1, and we also want that to be equal to the base. The base is 1/3. Those are my two convenient locations. I don't have to solve for them. They are essentially pretty straightforward there. Now, I need to plug those into my equation. So x will be equal to 1 and x will be equal to 1/3. So if I plug in 1 into the value of x, 1/3 to what power gives me 1? Well, that's has to be 0. So that output of that expression is 0. 0 plus 2 will give me an output for the entire function of 2. So I can plot 1, 2. The next point that I will evaluate is, what is the log base 1/3 of 1/3? Well, the output of that would be 1. I'd have to take that 1/3 to the 1 power. 1 plus 2 will give me a value of 3. So let's plot those points. So we'll say that this point right here is, we'll call that 1/3, 3. And then I'll have a 1, 2. So this will be a third. Maybe this is 1, and this will be 2. So we'll call that 1, 2. And then we will approach the asymptote and come through. That is not the greatest graph. I'll try it again. There we go. Okay, so we have found the domain and range, and we have sketched the graph. You want to try one yourself? Welcome back. Once again, be very careful. The only value that's in the logarithmic function is x, not x minus 1. If they wanted that in there, they would have had that in parentheses, and it is not. The domain then is the values of x must be greater than 0, because we have to have a positive value for input to the log, and the range is all reals. And so we have a vertical asymptote at x is equal to 0. And so we're going to be to the right of that. We now need to find our two convenient points. We take the input to the log and we set it equal to 0. And we take the input to the log and we set it equal to the base, which is 1/10. And then we will I would construct an X and Y chart, evaluate the entire function when X is equal to 1. That log base 1/10 of 1, it is 0. 0 minus 1 is -1. Okay, and then when I have an input for X of 1/10, if I were to plug in 1/10 in for X, the log base 1/10 of 1/10 would give me an output of 1 because I would have to take that fraction to the 1 power. 1 minus 1 gives me 0. Okay, now I can plot these 2 points and I find a point of 1/10 comma 0. That's my first point. And my second point could be probably located quite a bit to the right. That'd be 1, and maybe that's located something like this, 1 comma -1. And then I can draw my smooth curve. Okay. Hopefully it's starting to make sense. Follow the procedure. X plus 3, that first step, find my domain. X plus 3 must be greater than 0. Therefore, X has to be greater than -3. That is my domain, and my range is all reals. We have just essentially found our vertical asymptote, which will be located at X is equal to -3. Once I have done that, I find two convenient points to plot. I do that by setting what is my input to my log equal to 1, and we also set the input to the log equal to the base, and in this case the base was 5. I then solve for the values of X that make those true, and I will find that to be -2, and I will find this one to be +2. I would then construct an X and Y chart, and I would then find my output values of my functions when the X's are equal to -2 and 2. So I'm going to plug in -2 first. -2 plus 3 gives me a +1. Log base 5 of +1 is 0. Okay, so 0 times that -1, which is in front of that log, is still 0, and 0 plus 1 is 1. If I plug in 2 for X, 2 plus 3 is 5. Log base 5 of 5 is 1. I have to take 5 to the 1 power to get an output of 5. And so that will give me 1, but I have a negative in front of that. And so I have -1 plus 1 gives me an output for the function of 0. And they'll give me 0. Now I have my two convenient points that I'd like to plot, and I'll say this one was approximately negative, come on, Deb, -2 comma 1, and I'll say this one is 2 comma 0, and then I can put a smooth curve in there approaching that asymptote. Hopefully it's starting to make sense. Okay, next one, which is the last one of the day. I need to follow my procedure. I want to find my domain. I have to find that X minus 2 must be positive, and so I find X is greater than 2. We have essentially just found our asymptote, and our range are all reals. So I will kind of sketch my graph. I have an asymptote located at X equals 2. This is a vertical asymptote. And I then need to find two convenient points to plot. I find them when the input to that log is equal to 1, and when the input to that log is equal to the base. The base is 4. That occurs when X is equal to 3 and when X is equal to 6. Once I have these values of X that we can conveniently plot, I will then construct an XY chart, 3, 6, and I will plug in for x the value of 3. 3 minus 2 is 1. Log base 4 of 1 is 0. The negative of 0 still is 0, and so my output to the function is 0. Then I will plug 6 in for the value of x. 6 minus 2 is 4. Log base 4 of 4 is 1. 4 to the 1 power is 4. So I still have, however, a negative outside of that, so that becomes -1. Now I can plot these points. I can say that this is approximately 3 comma 0, and then I have a point of 6, we'll say 6 comma -1, and then I will try to put in a smooth curve through those points, and I have now followed the instructions. I have provided my domain, my range, and I have sketched the graph. I hope our lesson makes sense. I find that practice makes perfect, so please, please, please take your homework and ALEKS seriously. I think that once you do a few of these, it starts to get a little bit easier and makes more sense. So reach out to me if you have any questions.